Hello everyone. Today we will see definition of a vector space. A non-empty set V is said to be a vector space over R if there exists addition and scalar multiplication with respect to which V is closed. Now you already know the definition of set closed under addition and set closed under scalar multiplication. If you are not knowing the definition, then I suggest you to see that video first and then come to this definition. So what I said that a non-empty set V, remember it should be non-empty. A non-empty set V is said to be a vector space over R if there exists addition and scalar multiplication with respect to which our V should be closed. Further, for all u comma v comma w belonging to V and alpha beta belonging to R, this following 8 properties should be satisfied. First property is commutative property. So in order to understand this property, we will take the help of these two examples. Okay, so for some properties from P1 to P8, I will take help of first examples, and for some properties I will take the help of second example in order to understand these 8 properties properly. Now let us go for the first property, that is P1. So just remember, this UVW are elements of V and alpha beta are elements of R. So our elements of V should satisfy this condition, that is U plus V should be equal to V plus U. So what is the meaning of this? So the meaning is, see, if you add 2 plus 3 and just a minute, if you add 2 plus 3 and if you add 3 plus 2, so you can easily see that we are getting the same answer, that is 5 in both the cases, even if we interchange their positions. So this is particular for only 2 elements, but this should be satisfied for any 2 elements U and V of V. That is our commutative property. Second one is associative. So what do you mean by associative property? See, this U plus V plus W should be equal to U plus V plus W. Note, bracket is given over here. So first of all, we are going to add this U plus V, and then we are going to add W in it, and over here on the right hand side, first of all we will find V plus W, and then we are going to add U in it. So we should get the same answer for left hand side as well as right hand side. For example, we'll go for 2 plus 3 plus 6 suppose, and we'll go for the right hand, actually it is the left hand side. What about the right hand side? Be 2 plus 3 plus 6. Okay, so if you solve it, it will be 5 plus 6, that is 11. And what about this again? It will be 2 plus 9, that is also 11. So you can easily see that the associative property is satisfied for 2, 3 and 6. So such type of property should be satisfied for all the elements UVW of V. Now the third property is existence of identity. So there should exist 0 belonging to V such that U plus 0 should be equal to U. So meaning of this is, if you take any element of our set V, then we should be able to find, there exists means what? We should be able to find an element in V such that I am calling that element as 0 over here. Remember, it is a bold 0, such that u plus 0 should be again equal to u. So what is the meaning? So I will give one example. For example, for this R, if you are having 10, so after adding which element in 10, you will get 10 back. So you can easily guess that should be 0. So for this first example, our this bold 0 is going to be our usual 0. But for the second example, now second example is nothing but collection of matrices. So if I take one matrix, so by adding which matrix in this matrix, you will get that same matrix back. So you can easily guess it should be a matrix having all entries to be 0. So for this second example, our this bold 0 is going to be what? This one. Okay, our bold 0 will be this one. Okay, so depending upon the set V, your 0 may change. So this is about the third property. Now the fourth one, existence of inverse. So in this property, what should happen is, for each element of V, we should be able to find an element in V such that u plus minus u should be equal to 0. So for each u belonging to V, we should be able to find minus u belonging to V such that u plus minus u is equal to 0. Now note, whatever 0 has appeared here, the same 0 is appearing here. Now for example, for the fourth property, if I take example of our matrix 1, 2, 3, 4, okay, and on the right hand side, what was our bold 0 for this second example? It was matrix with all entries to be 0. So now can you guess that which element should be here, so that on the right hand side I will get a 0 matrix? So it's an easy guess. What it should be? Minus 1, minus 2, minus 3 and minus 4, right? And we are calling this element as minus u. This element is nothing but what? Our u. So you can easily see here, that is what the property is saying. For each u belonging to, this is our u, so for each u belonging to V, there should exist, there exists means we should be able to find minus u belonging to V such that u plus minus u is equal to this bold 0. Now the fifth property. So what is our fifth property saying? This alpha u plus V should be equal to alpha u plus alpha V. Again I will explain this with the example. Okay, we'll take the help of second example. Suppose I am having two matrices 1, 2, 3, 4. The second one 5, 6, 7, 8. Now I will take my value of, this is u actually, so that you will understand it better. Notation doesn't matter actually, so I will call it as u, and this is our V, because these are elements of V, right? So elements of V are denoted by u, V. Now alpha, I will take my alpha to be some 2, okay, or some other element also we can take, but okay, I will take it to be 2. So what will be this property actually? Our left hand side will be 2 inside the bracket, right? 1, 2, 3, 4 plus 5, 6, 7, 8. Isn't it? Alpha dot u plus V. This is our alpha, this is u plus V. And what will be our right hand side? our right hand side will be alpha is 2, our u is 1 2 3 4, plus again you are having alpha, so this 2 as it is, and what is our v, that is 5 6 7 and 8. So what should happen, this left hand side and right hand side should be same, so you can verify yourself. We will get that LHS and RHS will be same. Now we have checked this property for only for particular elements in fact, but this property should be true for what, for any alpha belonging to R and any u comma v belonging to what, capital V. So this is our fifth property. What about sixth one? Sixth one is the similar property, but here alpha and beta is there. Okay, so you should have one more value. So remember, this alpha beta are elements of R, so I will take it to be some 5, and V I will keep it as it is. Okay, so your left hand side will be, now in this case we are talking about sixth property, so left hand side will be alpha plus beta means 2 plus 5, and this is V, 5 6 7 8. And what about our right hand side? Our right hand side, just a minute, our right hand side will be alpha is 2, V 5 6 7 8, plus beta is 5 5 6 7 and 8. So again you can verify, you will get LHS is equal to RHS. So again this should be true for any alpha beta belonging to R and V belonging to our capital V. Now coming to seventh property. So in seventh property again alpha beta is involved and V is involved. So I will keep it as it is. So what will be our left hand side? Left hand side will be 2 multiplied by 5, and our V is 5 6 7 8. Okay, and what about our right hand side? Our right hand side will be alpha, that is 2 inside the bracket, beta is 5, and our matrix is 5 6 7 8. So you do the calculation, again you will find that LHS is equal to what, RHS. But note, while doing the calculations here you are going to take the product of 2 multiplied by 5 first, means this will be, if I simplify it further, 10 multiplied by 5 6 7 8, and over here first of all you are going to solve this bracket, right? So this will be 2, and inside the bracket, yes, you can put this 5 and inside and multiply to each element, you will get some matrix over here, and you repeat the same process, then you will find that this LHS and RHS is same. Over here 25 I think, 30, and you can find the rest of the elements. You can further do the calculations, 50 60, you can check it. Okay, and RHS and LHS will be same. Now what is the eighth property? The eighth property says that this 1 dot V should be equal to V always. This is easy to see. So 1 dot V, I will keep it as it is, 5 6 7 8, and you can see that again we will get what, 5 6 7 8, means we are getting our V back. Okay, but remember how we are getting it, what is the logic behind it? Actually we are multiplying this 1 inside to each and every element, but you know 1 multiplied by 5 is 5, 1 multiplied by 6 is 6, and so on. So therefore we are getting V back. So thank you, we will stop here. In the next class we will go for few examples of a vector space. So thank you.